All right, so this is question 9, the mechanism question, and the first part of this question was apparently answered fairly well, though people were making a few mistakes. Again, I apologize, this should have been D to correlate to that structure there. There was just a typing error that crept in when I put together the test, and I do apologize for that. All right, so the first question is the activation energy for the rate determining step of in this whole reaction. And the rate determining step must be the one that has the highest activation energy, which clearly is this first one over here. And the answer to that is H, because H is defining the actual activation energy. E is the transition state. All right. This just comes from the way that we've taught things. If you look at all the activation diagrams, this is normally the way that we label these. All right, energy of the third transition state, all right, A to K. The transition state, E is a transition state, F is a transition state, G is a transition state, all right, and that's the energy of the third one, 1, 2, and 3, so it should have been G over there. All right, is the reaction exo or endothermic? Apparently, all of you got this fairly easily. It's endothermic because the product is at a higher level than the starting material. So again, this was, as I said, done pretty well according to the lecturer who marked this. And then how would you describe this reaction? Is it an SN1, SN2, E1, or E2? Well, forgetting about whether it's a substitution or elimination, which should be very easy for you to see, and apparently you didn't see this, the SN2 and the E2 reactions all occur in one step. They have energy diagrams that look something like that. This clearly doesn't have that. So it cannot be an SN2 or an E2 reaction. Now, is it SN1 or E1? Well, this should also be very easy because E1 is elimination. Elimination gives us double bonds. And I don't see a double bond in the product over there. So it cannot be an E1. It must be an SN1 reaction. The thing is, I wanted to check that you weren't guessing this, and that's why I asked you to give a suitable reason for the answer to this. And so there are actually a number of different things that you could have said, but the first thing is that well, it's a substitution reaction, all right, because the bromine is going to an OCH3, a methoxy group. All right, that's one valid reason for this, is that you're substituting bromine for a methoxy, so it must be a substitution reaction. It also has 3 steps to it. We know there are 3 steps because 1 and an intermediate, 2 and an intermediate, and last step going to the product over there. So you could write there are 3 steps, so therefore not SN2. Okay, you need to have some sort of logic in the way that you're answering these reactions. Also, it could be 3 steps. You could say that they're 3, or you could also say they're 2 intermediates. That would also have been acceptable as well in this answer. And then the last question, the mechanism, was answered incredibly poorly, I was told. And there's some really fundamental problems that people experience in this sort of reaction. You had to show each of the stages, each of the steps, and you had to explain what was going on and label it as per the reaction mechanism. Now, if we're starting with this, which is compound A, all right, from the diagram, that's A over there, A goes to B, all right, B is an intermediate. If it's an SN1 reaction and there's an intermediate, it must be a carbocation formation. That must have happened. And so the only way that can happen is that the leaving group leaves. The bromine takes its electrons with it. A lot of people had some very strange answers where they're pushing electrons in like this. That's incorrect. Bromine doesn't give its electrons to the carbon. It leaves taking its electrons with it. All right. And so our first intermediate must be the carbocation, which looks like that. So that will be B over there. Then we go through another transition state and we get C. And we're now moving towards the product, and this is where some weird and wonderful things happen. So some people, because they saw what the product is, that you kind of got confused and you said, well, what I want is I want that to connect there. So I want an OCH3 minus. The point is you don't have that. What you've got is methanol, all right? That's all you have. You don't have an OCH3 minus, and this OH bond cannot spontaneously separate. This over here, this sort of thing, going to H plus OCH3 minus, does not happen, all right? This cannot happen. You cannot just have spontaneously water or a proton splitting from an alcohol. It does not happen. It's a very difficult reaction for that to occur. You've got to add a strong base for something like that to occur. All right, this is the equivalent of taking O, all right, that's water, and saying that water just spontaneously forms H plus and OH minus. It does not do that. If water did that, there could not be life on this planet. All right, it does not do that. And so the same thing happens over here. All we needed to do is we just recognize that we've got lone pairs of electrons. We're not going to break any of the bonds here. We're not going to break this OCH3 bond as well, which a lot of people did. They decided that somehow that bond needed to break. That does not occur. It cannot happen. We don't break our carbon-oxygen bonds unless we've got a very good reason for that to happen. All right, so we've got lone pairs of electrons on the oxygen, so they can add and give us our next intermediate, which is C, O, H, CH3. All right, and plus, that is our third intermediate over there. It's not the product yet, because the product doesn't have an H on the oxygen. All right, so here we've got the positively charged. This is the oxonium intermediate, just as this was the carbocation, and the oxonium intermediate is just the protonated form of the product. All we need to do is this has to just leave, and there are many ways of doing it. I'm quite happy if you just show it moving like that and the H leaves. If you want to show the H being picked up from something, well, you could show it being picked up from perhaps some of the leftover methanol that's in the reaction medium. All right, that could pick up the H and get protonated itself. That's fine if you wanted to do that. Okay, and then of course, then we go to the product, which is D, but you didn't necessarily need to show that itself. All right, so that was the last question for this paper. I want to wish you luck for the exam. Please take note of the way that I set out the class test. There are slightly different questions to what have been in previous tests and exams. It's important that you understand that because some of the format of the questions that we had in the test, you're going to see in the final exams. So make sure that you just are aware of the way that those have been asked, that you learn how you should be answering questions like that for the exam, and then you hopefully should do very well. All right, so good luck with that.